For lesson 7, we're going to talk a little bit about automation. Up until this point, we've covered tooling, we've covered basic operations, we covered feature recognition, like the lesson part you see here on the screen. We've done interactive, we've done automatic, but what about creating rules and creating some of those standards in automation? So today we're going to do a fairly high level, simple overview, sort of show you how to set them up. Obviously, every company is going to have specific needs that are unique to their process. So today's structure is just more to show you how you can leverage some automation. Now, I'm not talking about reusing data or templates or anything like that. Like, what I'm talking about is more of the rules-based machining, similar to what SOLIDWORKS CAM has. So we're going to start with a blank template, but we're going to reference this here because there are certain things that come into this, like the naming convention of the feature, like complex pocket, complex step, MAF, machinable axial features. So we'll be popping back and forth between this and a blank template. Keep in mind, I can create rules on the fly inside of this part, but for the sake of just sort of showing you how they can be done separate or together, I'm going to try to balance that. So the first thing we're going to start with is just a new PPR context. So I'm going to create a new PPR. And in mine, through my workflow lifecycle, I have to put in something in the BOM description here. You can set these up to be all different kinds of stuff. As you can see here, we have serial numbers and different types of tests. But I'm going to create a PPR context. And then I'm going to create a manufacturing cell. And these are all things that generally happen automatically on the fly anyway. Up until this point, we just haven't worried about it. Now I'm showing you that you can manually create all this stuff and create the blank templates if you want, or the blank layouts, and then put data in later. You don't have to always insert the part and then click on the compass, the programmer app, and have it build it. You can manually create a PPR and a manufacturing cell and then put them together. So if I go to my PPR, I'm going to insert an existing resource. So I'll just pick this one that I created. I could go pick anything, like I could drop in this lesson 3 if I wanted to, but I want to create these sort of separate so you can see how they work. And then we have a tab called Machining Process View, and it exists in any PPR context, okay? So again, you could create these on the fly if you wanted to, but for our sample playground, I'm going to create them in their own template, and then once they're in a template, I can leverage them anywhere at any time. So once we have a PPR that's been created, and you could go through if you wanted to, and I have one in my library called Master, and that's sort of where I keep all my rules I create, and then I can leverage those at any program I want. So to rename that, I'll just right click on the PPR, and I'll do lesson 7, rules automation, and make sure that I have my BOM description. Yep. So hit apply. And now my PPR is going to be called that. So when I pull it up in the future, I have one called lesson 7 rules. If I save that, now I can search and find that. And that's like one location where all my rules get stored. But the way that you set up rules is actually sort of simple once you know how the process works. So we'll start by going to our programming tab. And what we want to do is we want to create a new machining process representation. And what that does is it sort of creates a subfolder. And in that folder, you can give it different names. So let's say instead of machining process 1, I want this grouping to be called pockets. I don't know why I would call it that, but let's just say I want to call it pockets, right? And you could put in descriptions and all that good stuff, right? So I have a main folder called pocket. And then inside of that, I can create a new machining process if I wanted to. So you can create different groups and subgroups. And once I have that, then I basically go through and I start setting up the operations that I want to be as part of that subgroup. So this one can be internal pocket. And if I had geometry, I could pick it, but the focus of this is not the geometry. The focus of this is setting up how you want to machine the component. So do I want it to be an open pocket or a closed pocket? Do I want the bottom to be a blind or a through pocket? Do I want an offset on the bottom? So let's say I always want to rough, and leave 10 thou on the bottom. I could set those values in here. And what I'm doing is I'm setting the standardization that I want. If I had multi-axis like in here, I could set the multi-axis I want. Collision checking, whether I want kinematics turned on. I can set my lead in, lead out, my clearances here that I want. And then I can also set all my feeds and speeds the way that I want them to be. And so what I do is, in this machining process, I'm going to do one that's called an internal pocket. And maybe I do roughing and finishing, or maybe I just do finishing. Or I could group a bunch of operations together. So if we were talking drilling, I could do spot drill, drill, thread. I could put those 3 or 4 together. And so I just sort of build out sample processes that I would normally do. And if you think about it from SolidWorks CAM, we have rough finish, rough finish, we have finish deburr. I could set up those same types of things here, but instead of going into a database and filling them out, what I'm actually doing is I'm creating the steps just based off the operation. So let's say inside of here, I also want to add a deburring function. So in this instance, I could tie it to whatever the part is selected. And then all I'd have to do is specify the sharp edges that I want to pull. And from here, then I can set everything up. So now if I run this operation called pockets, it's going to do an internal pocket, and then it's going to auto deburr. So you can go through and you can make these as simplistic or as complex as you want. But what you're really doing is you're creating this group, and then in the group, you're setting what you want it to be. Now, the other thing that comes into this is once I have these operations set how I want, and I'm going to delete this one so it's not confusing. So we have one called pockets, and maybe we rename that. And we do internal blind pocket deburr. Whatever makes sense to us, right? So we'll save that. So what we can do is you can set up lists, as many of these as you want, and you can have a really complex set of operations. And then what we start doing is we start defining how we want it to behave. So one of the things we can do is there's a tool query. So if I open up the tool query, I can tell it, hey, when you go look for this here, when you find this pocket in this geometry, I want you to query my catalogs. And in lesson 5, we talk about catalogs. And I have one called inch tooling generic. I want to do a query, and I want to use an end mill and a tool assembly. So I want a regular end mill, tool assembly. And then I want to define that tool based on something. The axial depth of cut. I could also do, there's a diameter one in here. I want the cutting diameter to be equal to or less than whatever you want to put in. I want it to be equal to, and I'm going to go to my machining feature, and I'm going to pick, go down just a little bit more. I'm going to pick a prismatic feature or prismatic pocket as an example. There's different types of features you can use. Some apply to what we do from a SolidWorks perspective. Some of these are actually more advanced for areas like CATIA or some of the X apps. I can also do a machining feature. And as I click on those, then I can say, well, I want it to be related to something here. Now, you may be asking yourself, well, how do I know which one to pick from the list, right? Well, that's where these sections relate to what we're doing here. So when we ran feature recognition before, you notice we have, if I expand this out, we have a complex pocket, we have MAFs. These naming conventions are actually what we're searching for. So if I look at the information on this, here is all the information that gets captured when a feature is created. Here is all the settings that we're using, and then you can see that this actually becomes a complex pocket. So when I'm writing these rules or leveraging these rules, as we do in here, if I come back to my query, if I click on the PPR, my bad. If I look at the tooling query here, this is where I can start saying I want it to be cutting diameter equal to, and then we want it to be machining features, and then we can start looking for the type. And if we were doing axial or holes, it would be MAF. If I do machining feature, then it would be back up here, be main type of object, and then I can say I want it to be equal to the type of object here. Or if we scroll down, if I want it to be a prismatic machining area, then I can go to area type. I want it to be a pocket. So I can say, well, first I want the cutting diameter to be equal to a pocket. And then if I push that up, there's the one rule. And then beyond that, I want it to be equal to the minimum corner radius. And we'll say times 0.8. So I want it to be 80% of whatever the minimum corner radius is. So I can write multiple rules throughout this entire process, and I can really narrow down when this pocket becomes applicable. So I can write as many rules as I want in this list, or I can keep it simple and just say I just want one rule in here. Likewise, if I come over to the first one, and in here I can say, what do I want it to be? What limitations do I want to have on the tool? Well, I can say that I want the name to contain the word flat in it. That means it's going to search for an end mill that has the name flat in the name, and then it's going to look at the minimum corner radius of that pocket and make it 20% smaller. So if I hit OK, that tool query is now going to come into effect. So when I run feature recognition, or I assign a feature, if we look at this, and we look in here, let's say I look at this complex pocket, the minimum corner radius is 0.3. So what that pocket's going to do now when I run the rule is it's going to look at this and say, okay, I'm going to pick a tool that is 80% of that 0.3 radius because this is a blind pocket and it meets those criteria, right? So it's a blind pocket, it has a depth, it's got a hard bottom or blind. Then it's going to look at this data and say, okay, I'm going to read any of these parameters that are spec'd, so I'm going to pick a flat end mill that meets 80% of that value. And if it exists, then it's going to automatically create that operation for me using the parameters that I have set in this operation. Sounds complex, but it's doing the exact same thing like what SOLIDWORKS CAM would do. The only difference is between a database and here is I can write these rules to be whatever I want, and then I can apply these as I need. So what it's going to do is it's going to call a prismatic machining area. It's going to automatically fill out the bottom, fill out the guide, fill out the tool axis. That stuff's going to be taken care of. Then it's going to come over here. It's going to do outward helical. So if I wanted everything to always be concentric, here's my concentric. It's going to auto fill out all of these settings for me and pick the correct tool that's needed. And I can do the same for here. I can say, well, for deburring, on this one, I want to pick a ball end mill. And for this one, instead of searching for a query or a list, I can just say I want the cutting diameter to be equal to 0.25. I don't know why I would want that, but let's say I want it to be that. So what it's going to do is going to look for a 1/4 inch ball end mill, and that's the tool it's going to pick. And I could look in here and I could say I want the name to equal ball. Or if I had some special type of coding that I had in here, then it would find, a part number or a serial number or my company ID. It would look for that, equal that, and then it's going to pick one. So it's going to find a ball end mill that's a 1/4 inch, and that's the tool query that it's going to use for deburring. And then once it finds the tool, it's going to add all of these parameters automatically and calculate the tool path. And then on top of that, if I wanted to go further, I can actually, let's say I had 100 different rules that I created for how I program. On top of that, I can actually go to here and I can create checks that will tell it to either look further down this group or just skip over it if it doesn't meet criteria. So I could say, well, I want machining features and I want a prismatic machining area. And if for this instance, I have a blind pocket. So I could say, well, I need the prismatic area bottom to equal hard. And if I put that up, then what it does is it looks at the feature and says, okay, is it a blind pocket? Yes or no? If it's no, then it just skips over this and goes to the next one. If it's yes, then it comes down and says, okay, here's an internal pocket. Does it meet this query? And then here's deburring. Does it meet this query? So you set up how you want it to be machined, sort of like a template. But then when we run these machining processes, it takes care of all that automation and calculation on its own. So once these are set up, let's say you went through and you created a bunch of them, right? You can take any of these and actually send them to a catalog. And then once you have a catalog, you can add to them or create new ones. So I'm going to create a new one here just for lesson 7. So I'm going to create a new catalog. I'm going to call this lesson 7. We'll hit OK. And then that catalog, once it's stored, I can use it anywhere. I can use it at any time. If I create more rules, I can always add to the catalog over time. So let's say I find myself programming something and it's like, boy, this would be nice to just automate and let DELMIA do it. I can then just pop in, create a manufacture or machining process, save it to the catalog, and then it's available to use anytime going forward. So you have the ability to build it on the fly, or you can sit down and capture all the rules that you have for how you machine and then automate it down the road. So once the catalog's saved, you can continue to store or save the PPR and come back to it. To give you another example, I'm going to open up one that I have and I've created. So I have one called Machining Rules Inch Template. So I'm going to go ahead and open this one up. And this is the PPR, the repository that I use every time I want to come back and create one. I put one in here and then I just send a catalog, and then I have a catalog, which is Machining Rules Inch Generic. That's the one I actually leverage for use, but where I create it is in this one PPR. You don't have to do it this way. This is just more how I manage it because it makes sense to me. So if I look in here, you'll see that I have ones for drilling, center drill. Then I have drilling drill, counter bores. Then I have all different kinds of pocketing that I use, whether it's blind or through with different radii. And these rules for me, line up with the ones that I generally use in SOLIDWORKS CAM. So I have lots of different rules that are used in here. And if I look at, let's look at one of the tooling queries here. So I have cutting diameter equal or less than the prismatic machining area, minimum corner radius 1.8, or greater than. So I'm still looking at that prismatic machining area, and then I'm looking at the minimum corner radius. And then it's also calling out that for this instance, it has to be a flat because I'm looking in one with no radius. So if it sees one with a radius, then I'm actually picking a hognose tool. So not only am I querying whether or not this operation is useful, then I'm actually interrogating what that feature is to determine which tool I want to use or whether I want to use a tool. So if I look at edit checks on this, I'm actually qualifying this through 3 calculations. It has to be a pocket, it has to be blind, and then it's an area clearance. So the type of pocket, because this is actually an open pocket, not a closed pocket. So in this instance, I'm going to search for a blind pocket that has a radius in the bottom that is also open. And then once it sees these criteria are met, then it comes down and can do the rest. So hopefully this gives you an understanding of how the rules work, because you can write the rules to be sort of whatever you want them to be. And then once they're sent to a catalog, you can use them in any part. So if I look at this part here, if I have a part and we go through the process that we went through up until this point, right? Let me make sure that this is the current machine. And this is a random assembly that I pulled up, but it has, I believe, has some features in it. So let me look here and turn on, see if we got any features that have been created. So there's some axial features and there's some internal pockets and then there's some patterns, right? Whether I use automatic feature recognition, interactive, or I come here and I manually create them, once I define what the feature is, I have information that I can run the rules based off of. So for this example, and we'll just try one here really quick, I'm going to go to programming and then I'm going to say I want to apply a machining process. And at this time, it's going to go look out in my common space and it's going to see what catalogs or rules are there to pull. And, you know, depending upon how fast your internet is, how many rules you have, it's going to come up and say, okay, what features do you want me to look at? And I can pick all the features, or I can say, I don't know, for this one, for a sample, we're just going to pick these 2. I don't know why, but we'll pick those 3 pockets, right? So I want you to look at these features to automate. I want you to put these when they're done in this area. So I want it under that tool change. I don't know why, but we'll say it can be there. And then I can pick what type of queries I want it to be. Well, I know that these are closed pockets with no radiuses, so I'm going to simplify this a little bit, but I could have it just calculate everything automatically if I wanted to. I could pick this whole list, let it go figure out what's best. For right now, I'm just going to say I want it to be a closed pocket, blind, no radius. Hit OK. And what it's going to do is it's going to interrogate the pocket. It's going to go out to my catalog of tools, pick the correct tool, bring it over, create all the tool paths, and apply all my settings. And once it's done, you'll see that what it did is it went through, it found that it needed a tool change. So it put in the correct tool change at that point in the program, and then it went through and created the 3 different pockets for me automatically. Now in this instance with my program, it came back and said, hey, the tool's too big, you may want to make a tool change to that. So with that, I could manually still swap out the tool, which gives me full capability to make a change if I want to. So let's say instead of this 1 inch, pick here. We'll say that I want to use a 3mm end mill. Even though I ran the automation, I can still change anything at any time. So now if I come back, I activate this. I think through talking and driving, what I did is I didn't actually change the tool out here. So let me change the tool. I can also manually change it for each operation if I wanted to, but you can group change these however you want. The key here is through the automation, what we're doing is we're quickly adding the rules that we want, but we're not taking away your capability to make changes or adjustments. So you can see here it now went to the pocketing 11. But I want to change this one. And you can control pick or shift select these and change them all as one group, but sort of show you the process. So I'm going to pick here, I want an end mill. And part of this is to show you that even though they're independent, or even though they get automatically created together, I still have full control to make a change at any given time individually. It's not an all or nothing type thing. So the benefit of these rules are I have the option to make it what I want, even though I'm truncating the clicks that I need to actually make this work, because I'm letting the software do the rules, and then I'm coming back and actually adjusting it further if I wanted to. So you can see it's an end mill 3mm flat end. And then from there, I can continue to further refine this. So the point of all of these rules are, even when I'm creating them, whether it's in a part or I'm creating them in their own to write the rules, once they're there and stored in a catalog, I can leverage those rules at any given time. So if I ran that and I decided, that came back and found a 1-inch when I did no closed pocket blind, no radius, maybe what I need to do is edit the tool query, and you can see in this one it just calls out for flat, and there's no query in this. So I need to go to machining features, and I need to say, okay, I want to look for prismatic machining area, and I want the minimum corner radius times 1.8. Don't know why, but let's say that that's what I want. So I'll do that. I'll hit save. This saves this. And then what I can do is I can actually go through, and on this one, I can do send to catalog, and I can say update existing catalog or library. And then when I hit OK, it's going to give me the ability to update that. So if I have different catalogs, I can update and append this. So I can have one catalog with all my tools and my rules in it, or I can have one catalog for tooling, one catalog for rules. You have the ability to make these updates, but the key is I can change these on the fly as I test them out, and then I can always come back and just rerun this over here, and away we go. So once that's been updated, then I could come back here and I could pick my machining processes, run it again, and then see what tools come into play here. So it's sort of saving the favorites as you go, or you can write the rules as you go, or things that you find over time. It's really endless. You can create rules for mold making, or rules for water jet or plasma or laser. You can keep them all separate if you want. So if I look in mine here, these are ones that I've grown over time from programming. It can really become whatever you want. And you can make the rules complex or very simplistic, like I just want I just want one for pockets, and then inside of pockets, instead of having pocketing 2 and then a query, I can have one group called pocket and have every different combination I want underneath of it. You can also create different revision schemes if that's what you want. You can do center drill drills, counter bores, pretty much whatever you want to do. It's not just 2.5 axis. You can do surface machining and roughing and things like that. But the key is once it's there, I can open up a part, pick my features, run my rules, and it'll program it. So hopefully that helps explain a little bit of how the rules work. You don't have to use them, but they sure do help when you have a lot of repetitive things. Like this part is an example: pockets, bosses, holes. Instead of clicking all that stuff every time, I can just run feature recognition, apply my machining processes, and it'll build my entire operation list for me. And then all I have to do is just make sure everything's the way I want it.